So this is the example from class, which was f of x equals square root of x, and the domain is 0 to positive infinity. We're mapping onto the real numbers. So we want to show that that this is uniformly continuous, meaning that for any x and y we pick, if x and y is smaller than delta, that implies that f of x minus f of y is smaller than epsilon, right? So yeah, that's what we want to show. And uniformly continuous, how it differs in like proving versus like regular continuous, I guess, is that it for uniformly continuous, it does, our delta that we're trying to find does not depend on our x or our y, right? So yeah, so it should only depend on epsilon and constants, or I'm not really sure exactly, but I know it shouldn't have x or y, right? Because that's the definition of uniformly continuous, is that we should find a delta that works for all of them, right? For all the x's and all the y's. So right here, yeah, I'm just writing down the uniformly continuous like definition-ish, kind of shortened version. And so just emphasizing that that's what uniformly continuous is that it's for any x and y in the domain. And with continuity proofs, right, the main thing is that we want to find a delta that makes that statement true, the one that says such that x minus y, the absolute value of that is less than epsilon, implies f of x minus f of y. So we want to find a delta that makes that statement true, and we get to assume that the absolute value of x minus y is less than delta. So usually with these kinds of proofs, like we've seen, you want to do, or she just kind of jumps into the trick, which for these you just have to be kind of sneaky or like clever and try to find essentially a clever delta that kind of gets you to where you want, and that's where like the scratch work comes in. So yeah, right now I'm just writing what we want to show, and we can assume that, like I said, x minus y is smaller than delta, and f of x minus f, we want to show that f of x minus f of y is smaller than epsilon, which in our terms means square root of x minus the square root of y is smaller than epsilon. And this is where like the cleverness or like trickiness comes in. We know that so I'm just saying that we're focusing on positive numbers right now, positive values. So we know that the difference between two numbers is smaller or equal to the, like, adding two numbers. It doesn't really matter that there's a square root, like it's the same shit. Like all we're saying is that the square root, like essentially that should make sense. So now I'm just multiplying both sides by square root of x minus square root of y. Since that's a positive number, it doesn't change the sign, so we should be good. And right now that right hand side is like essentially like the difference of squares or something like that, right? Where like a squared, or a plus b times a minus b is a squared minus b squared, right? So kind of just manipulated this inequality to get it how I want it, just because I know where we're trying to go with this. But it would be kind of hard to figure this out if you didn't have like a sense of direction where we want to go with this. But this right here, the fact that we just found, is going to be like the main thing that helps us, right? So right now I'm just writing down, rewriting that inequality, and I'm adding the assumption that x minus y is smaller than delta. And we want to essentially show that square root of x minus square root of y is smaller than epsilon. So right now I'm just kind of manipulating so I can get to square root of x minus square root of y and see what like that would look like in terms of like delta, essentially, right? So if we just hit everything with the square root, and we know everything's square rootable, I guess, if that's how you say it, because they're all positive numbers, right? So we see that square root of x minus square root of y is strictly less than the square root of delta. So all we have to do is say, well, let's just have epsilon be the square root of delta, right? And we just hit both sides with the square, and we get delta is the square root of, or is epsilon squared. So we found our delta that works, yeah.